So we're going to consider another situation using permutations, and this is when we're looking at permutations when some of the objects are alike. Now, we could have a question such as how many distinctly different words can be formed using the letters of the word Ottawa. So you have to use all the letters. And one thing that we have to consider here is suppose it was possible to mark each of the repeated letters so that the two T's and the two A's could be distinguished from one another. By coloring these letters, so one of the T's red and one of the T's green, and one of the A's red and one of the A's green, we can create 6 letters that are different from one another. And these can be arranged in 6 factorial ways because there are 6 letters. So once we choose the first letter, if we can choose any of the 6 letters. So it'll be 6 and then 5 for the next, 4, 3, 2, 1, etc. So these letters can be arranged 6 factorial ways. Now, you'll notice that there are 4 different ways that we can rearrange this one. So if we have A, O, T, W, A, T, well, we could have here the A is red, and here the A is green, and there's a total of 4 different ways that we can rearrange this. And you'll notice when the coloring is removed, they form the same word. So the only reason that these are different right now is because we've used coloring. So there are 4 different arrangements that we can make using this in this order. So A, O, T, W, A, T. So since there are 2 factorial, or in other ways, 2 ways we can arrange the T's, and for each of these there's 2 factorial, or 2 ways we can arrange the A's without actually changing the word, there will be 2 factorial times 2 factorial, or 4 duplicates of the same word. And that's what we see up here is these are actually, if we remove the coloring, all the same words, but there are 4 ways that we can arrange them when there is coloring. Now, to correct this overcounting of identical arrangements, we're going to divide 6 factorial by the number of duplicate words that can be formed for each possible ordinate of the letters. Therefore, the number of distinctly different words is given by 6 factorial divided by 2 factorial times 2 factorial. And so this is 6 factorial over our 2 factorial times 2 factorial. So we're basically dividing by 4. And so our answer is 180. Now, in general, the number of permutations for a set of n objects. Now, if you just have n objects, you can arrange them n factorial ways. Now, if we have A, and this is a number, so if whatever number A is equal to are alike, B are alike, and C are alike, and so on, then the way we calculate this is n factorial divided by A factorial times B factorial times C factorial. So let's consider an example here. Determine the number of arrangements possible using the letters of the words mathematics. Now there are 11 letters, and there are 2 M's, 2 A's, and 2 T's. Therefore, the number of arrangements, if we're just going to consider the number of ways you could arrange this if they were not alike, it would be, if they were all different, would be 11 factorial. But we have to divide by 2 factorial because of the 2 M's, times 2 factorial because of the 2 A's, and 2 factorial because of the 2 T's. And so you end up with 4,989,600. Now, we could also take a look at selecting objects with and without replacement. How many ways are there to draw 2 cards from a standard deck of 52 cards? Well, without replacement, you can draw 1 card and then another without putting the first card back into the deck. And so there are 52 ways that you can select the first card, and once that's out of the deck and not replaced, then there are 51 ways of selecting the second card. So therefore, there are 52 times 51, or the permutation of 52 choose 2, which would be 52 factorial over 50 factorial, and it would simplify to be 2,652 ways of selecting two cards. Now, selecting without replacement, with replacement, if you select your first card, put it back in the deck, and then select your second card, well, there are 52 ways to select the first card and 52 ways to select the second card because of the replacement. So that means that there are 52 times 52, or 52 squared ways, or 2,704 ways of selecting the card this way. And so replacement increases the number of possible choices.